Welcome again. In the last video, I listed the 9 scenarios for expected alpha and Sharpe ratios. The average arithmetic return is unchanging in each scenario, but the perturbation risk ratio is different in each scenario. Condition 1 was derived in the last video. In this video, conditions 2 through 5, which will lead to scenarios 2 through 5, will be derived. As a reminder, here are the 9 scenarios which define the relationships between possible expected outcomes. Let's look at Scenario 2. Conveniently, deriving the conditions of Scenario 2 is identical to the derivation for the conditions of Scenario 1, with an equal sign replacing the inequality at every step, resulting in this equation. Assuming the covariance between perturbations is 0, then if the ideal betas are the same as in example 13.1, then the left-hand term of condition 2 is if the standard deviation of the perturbations for the high CAPM beta portfolio is 10.6275% and the standard deviation of the perturbations for the low CAPM beta portfolio is 9.3725%, then condition 2 is met. Because condition 2 is met, scenario 2 is expected. If we take the numbers from this quick example and plug them into the formulas of videos 12 and 13, we get, which means, for the same average arithmetic total returns and ideal risks as found in example 13.1, expected alphas and expected Sharpe ratios can change in magnitude and order depending on the relationship between the perturbation risks. Now let's look at scenario 3. Part of the derivation of the conditions of scenario 3 is identical to the derivation for the conditions of scenario 1, with the inequality reversed at every step. Assuming the covariances between perturbations is 0, then this gives us the condition for when the expected Sharpe ratio of the market is greater than the expected Sharpe ratio of the high CAPM beta portfolio. Now we need the condition for when the expected Sharpe ratio of the high CAPM beta portfolio is greater than the expected Sharpe ratio for the low CAPM beta portfolio. Here is the derivation beginning with the inequality. Making the following 2 substitutions and dividing by average excess return, squaring both sides and expanding gives, taking the reciprocal of both sides and canceling, subtracting like terms and moving things around, taking the square root of both sides gives us, tentatively, the full condition for scenario 3 is, this is too broad of a condition. While it gives the order of the expected Sharpe ratios, the order of the expected alphas changes within that range, and we need to capture the point where the order changes. So I will leave the condition for scenario 3 unfinished for the moment and move on to scenario 4. Also, there will be numerical examples for all the scenarios in video 17. There is no need to continue doing numerical examples as we go. Let's look at scenario 4, which is the scenario of the capital asset pricing model. The order of the expected Sharpe ratios is the same, but now the expected alphas are equal. To get the same order of expected Sharpe ratios, you need only review condition 3. Now we have to find the condition for equivalent expected alphas, which means 0 alphas. If the expected alphas are 0, then the CAPM form as we know it drops the alpha term, and this is still equivalent to the ideal form, which means the dividing line between scenario 3 and scenario 5 is when ideal betas equal CAPM betas, which implies we can set the ratios between them equal and expand the CAPM betas. Multiplying through by the denominator on the right-hand side, distributing the betas and subtracting like terms from both sides, multiplying through by 2 and moving terms around, assuming the covariance between perturbations is 0, then taking the square root of both sides gives the condition for scenario 4. Notice that this is not a range of values but an exact ratio, which is why CAPM is narrow and unlikely. Now we also have the correct condition for scenario 3. Next, we derive the condition for scenario 5. The condition for scenario 5 is available by inspection of the derivations of conditions 3 and 4. It is important to recognize that the expected alpha for the low CAPM beta portfolio is greater than 0 for this and all remaining scenarios. This is enough for one video. I will pick up in the next video by deriving the conditions for scenarios 6 through 9. At the end of the next video, there will be a summary table of the conditions needed for each scenario.